Okay, I have some examples here. Evaluate the given integrals. I look at these integrands. There's no way. Actually, I cannot do evaluate that integral if the limits are not choosing very carefully here. When you see such a strange integral, go ahead and try to see the symmetries. If the function is sine x over x4 minus 5x squared plus 3. Then when I plug in minus x for the function, I will see sine of minus x to the power 4 minus 5 minus x squared plus 3. Negative x to the power even number is always that x to the power the same number, because negative 1 to the power 4 is 1. And the same works with x squared. So denominator stays the same. How about numerator? Well, remember there is this property of sine, or look at the graph of sine function. Sine of negative theta is minus sine theta. So sine is an odd function. But that tells me that, oh, look, this whole piece here is my original function f of x. Now, some strange things happen, but at the end, what came out to be true is that f of negative x is minus f of x. So this means that conclusion is that f is an odd function. An integral of odd function on any interval from negative a to a. In this case, negative 1 to 1 is going to be equal to 0. Okay. How about this other one? Okay, so again, I define, since I already know that I'm using the symmetries, I define the function, the integrand to be my function, cosine x. And when I plug in minus x there, this will be minus x cubed plus 4 times minus x cosine of minus x. Minus x cubed is my negative x cubed itself. Negative 1 to the power 3 is negative 1 minus 4x, and cosine of any minus any theta is cosine theta. In other words, cosine is an even function itself. So this will give me just cosine of x. Factor out a negative sign here. And as you can see, what I have proved is that cosine of minus x, negative x is minus, f of negative x is minus f of x. So that means that f is an odd function. And when you have odd function and you go from negative a to a, it's very important. If you have different limits for the integral, that won't be true. But here, from negative a to a is pi over 6. This is always going to be close. For the third part, we are integrating t cosine t minus 2ft dt, knowing that f is an even function, and we have integral of the function from 0 to pi over 4. So to start with, I will separate the integrals. Then you can see to deal with the first integral, so if t is t cosine t, if you plug in minus t there, it will be minus t cosine of negative t, and this will be minus of f of t. So this guy is odd, so f is odd. And that means that the integral of that function from negative a to a is always going to be 0, minus 2 times. The second one, it says f is even, and integral, the given integral is from 0 to pi over 5. This is true only the function is even. Then integral from negative a to a is twice as integral of f from 0 to a. And this way we have 0 minus 4 times 3, which is negative 12. So just by looking at the properties or symmetries of the function, we were able to evaluate some of these integrals.